Let's take a look at another one. The U.S. Army requires women's heights to be between 58 inches and 80 inches. Women have heights with a mean of 63.6 inches and a standard deviation of 2.5 inches. Find the z-scores corresponding to the minimum and maximum heights. So here we had a minimum height. Our first value was 58. So they want us to turn both of these values into z-values or z-scores. So we're going to start with these one at a time. Let's convert the 58 first. Remember, the formula for z says to take whatever value we're given, and to convert it into a z-value, we subtract the mean first. Well, on this one, when we subtract the mean, let's read through the problem. What's the mean? The mean was 63.6. And then the last thing that we're supposed to do is divide by the standard deviation, just like we did in the last problem. Well, let's read the problem. What was the standard deviation? The standard deviation was 2.5 inches. So let's go ahead and plug in our values. Well, the first value they wanted us to convert was the 58 inches minus the mean they gave us was 63.6 inches divided by the standard deviation they gave us, which was 2.5 inches. And let's figure out what that value is. Remember, we do round z values always out to 2 decimal places. So let's see. So take the 58 minus the 63.6 and divide by 2.5, and we get a z value of negative 2.24. Now, however, they still wanted us to find two different z values. They also wanted us, this was the one for the minimum. They also wanted us to find a z value for the maximum height. So we need to use the formula all over again to find the z value for the maximum height. So we just have to use the formula all over again, starting out with the value for maximum height minus, again, the mean. And again, just like on the last one, we'll divide by the standard deviation. And then we'll talk about comparing these two. So the value that we're looking at first, that we're converting, is now the 80. The maximum height was 80 inches, so we'll use that first, 80, minus, the mean has not changed, it is still 63.6, divided by the standard deviation, which also has not changed, is still 2.5. So we'll do the 80 minus the 63.6 divided by the 2.5, which is, let's see, which is the 6.56. Question is, what do these z values mean? So again, if I were to draw a little mock-up, remember that when you've got z values, 0 goes in the middle. Remember, the high end of being usual is just the number 2. The low end of being usual is just negative 2. Now, the two values that they gave us, well, the minimum was the negative 2.24. Well, that's all the way down here, negative 2.24. Notice that the outside, the middle part, so that is going to be considered unusual. Now, the other value we got was, let's see, the 6.56, and let's see where that falls. Well, that's all the way on this end, way even further out, 6.56. So it's way outside of the middle part, which is going to be, again, considered unusual because it's not between negative 2 and positive 2. So both of those values are considered to be unusual. Now, z-scores or z-values do help you compare two things that appear to be very different, but if you turn them both into z-values, instead of comparing two things that are different, you're going to compare them on the same scale or the same number line. So z-values are very helpful to compare two things that otherwise would seem very, very different. This next example is a perfect example of comparing two values that would seem different on face level, but that if we turn them into z-values, we can compare them by turning them into the same type of thing. If they're both z's, we can compare them that way. So we have an ACT score and an SAT score, and we want to know which one's better. Well, right now they seem like apples and oranges. SAT scores are one thing, ACT scores are another. But if I can turn them both into z-values and put them on the same picture, I should be able to tell which one's actually a better value. And then it's more like comparing apples to apples. So what I need to do is they've got one SAT score, which is the 1190, and they've got one ACT score of 16. We want to compare those two and see which one's better. So to compare these two things, which seem very different, I need to turn them into z-values. So let's start out with the SAT score first, which says to turn these into z-values, you need to take whatever value it is you're concerned about and want to look at and subtract just like before. So we subtract the mean. And we divide by I'm going to shorten this a little bit, standard deviation. So I'm going to use SD for standard deviation. Let's see what happens here. So the value that we're looking at converting for the SAT score is the 1190. So we'll use that first. Minus the mean. Be careful that you subtract the mean we're talking about for SAT scores, because that's going to be different. Well, the mean for the SAT scores is the 1518, so minus 1518. And then we're going to divide by the standard deviation for the SAT scores. Well, if we go back, the standard deviation for the SAT scores was 325. So we'll divide by a 325 and see what we actually end up with for a z-value. So we'll take that 1190, subtract the 1518, and then we'll divide by the 325, and we get about a negative 1.01. Problem is we're not done. We still have to do the same thing all over again for the ACT scores. So we do the same thing again, same formula. We'd start out with the value that we're looking at converting, but this time for ACT scores, minus the mean for the ACT scores, and then divided by the standard deviation for the ACT scores. So first things first, what's the value of the ACT score that we're trying to convert? And that is the 16 minus what's the mean for the ACT scores? The mean for the ACT scores is 21.1. And then we'll divide by the standard deviation for the ACT scores, which was 4.8. And let's see what we end up with when we do all the math here. So we'll take our 16 minus the 21.1 divided by the 4.8, and we get a negative 1.06. So now these are both z-values. I can put them on the same picture. So let's go ahead and draw a picture here to see where they are. So here's my picture. Remember with z-values, 0 goes in the middle. The two z-values we have, let's put them on the number line. Well, the first one we have is negative 1.01. That's somewhere down here. And then the second value we have, is negative 1.06, and that's even a tiny bit smaller. So the question is, which one would I rather have? Well, notice our numbers get bigger as we move from left to right. So I want whichever one's furthest to the right. Well, the one that's furthest to the right is this one. That's my negative 1.01. So which one's going to be better for me is actually the SAT score. That one's going to be the one that's better for me.